Okay. Hi guys, and welcome to my channel. Um, Starstruck Rambler here, and today we're going to talk about planets. Um, Now this is gonna be several part episode, or I'm going to break this up into several episodes because there's so much to talk about, and it's going to be a sub series of the space series. So, yeah, let's get this first part up. Now, planets. Now, what exactly is a planet? Now, according to the um, to this international space agency, or the IAU, if I remember that correctly. Um, but this community, or this group of scientists, global scientists, if I got this whole gist correctly, back in 2006, um, or was it 2005? No, it was 2006. Um, that's when they decided to basically, a planet is an object that orbits a star that has enough mass to have pulled itself into a sphere, and it's not the moon. Basically, a planet has to orbit a star and not another planet like a moon, but its first orbit, um, or the main object that it orbits, is the star and not a planet or another planet like the Earth and the Moon, for example, or Jupiter and its four Galilean moons, Io, Europa, Ganymede, and Callisto. Yeah, those four are moons because they orbit Jupiter, but Jupiter is a planet because it orbits the sun. So, another thing that makes up a planet is it should have enough mass to um, clear its orbit of other objects, asteroids, comets, um, other dwarf planets, or basically its orbit should be more or less cleared of other objects, asteroids, comets, dwarf planet-like objects. Um, Also, a planet should have enough mass to influence objects around its orbit. Um, for example, if a comet or asteroid comes near a planet, this planet should a planet should have enough mass to do one of several things. One, redirect this object into a new orbit, um, or draw it in until this object impacts with it, um, like what happened with the asteroid that wiped out the dinosaurs. big rock slamming into the earth, boom, no more dinosaurs. Number three, um, the planet ca- captures the asteroid or comet or small dwarf planet object or dwarf planet like object into a orbit around it. Um, like for example, what happened with Phobos and Deimos, the two moons of Mars. Um, Most of the moons of Jupiter, Saturn, Uranus, Neptune, for example. Also with Neptune has captured, for example, Triton, which is a Kuiper Belt object or KBO. The evidence for this is that Triton orbits Neptune in the opposite direction of the other moons. Um, yeah, so those are the three things of what a planet could do with a passing object, directing it into a new path, drawing it in until it hits the planet, or captures it as a moon. Um, Also, its orbit should be relatively circular-ish or slightly oval-ish. Um, yeah, so under that categorization, we have 8 major planets: Mercury, Venus, Earth, Mars, um, Jupiter, Saturn, Uranus, and Neptune. Now, we also have a few dozen or so dwarf planets, Ceres in the asteroid belt, for example, um, Pluto, Eris, Haumea, Makemake, and a whole lot of others that I don't remember at the moment. Um, yeah, these are all dwarf planets because they all, okay, up to a certain point they do fit the categorization of the international um, te- team of astronomers. Um, they are orbiting the sun. They do have enough mass to have pulled themselves into a sphere under gravity. Yes, gravity does exist, you flat earthers. Um, I know it's not a conspiracy, you stupid flat earthers. If there are any flat earthers watching this. And yeah, and there, um, yeah, let me catch that trail of thought again. They are massive, massive enough to have pulled themselves into a sphere under gravity. Sorry about that. My brain was faster than my brain. Being stupid again. Sorry about this, guys. My brain is a bit mixed up now, but brain, catch up, please. Um, Let me do that over again. Now, dwarf planets orbit the sun. They have enough mass to have poured themselves into a spherical shape, and they do have enough mass as well to be able to capture moons, um, depending on the speed and angle of the two objects, dwarf planet and possible moon. But they don't have enough mass to properly clear their orbits of other debris, asteroids, comets, or other dwarf planets. Um, yeah, like for example, Ceres. Um, it has enough mass to have poured itself into a sphere, but because it orbits in the asteroid belt, it's classified as a dwarf planet. Um, and the same goes for Pluto. It orbits the Sun, has enough mass to have poured itself into a round shape, but because it crosses um, U- um, Neptune's orbit and a whole lot of other objects, comets mostly, it's classified as a um, dwarf planet. Oh, another thing I forgot, for a planet to be classified as a planet, or at least in our solar system, it should be on more or less roughly the same orbital plane, relative speaking to the sun's equator. Um, okay, it doesn't really count that much anymore, but it used to count. So, or at least I think it used to, but that was like a sub thing at some point, if I remember correctly. Um, yeah, there's so much stuff about space that I've read that I can't remember everything, but the stuff that I mentioned so far, except for the orbital plane thing, count. And yeah, that's about it for our solar system. Um, as for Planet 9, um, since we haven't found it yet, we're not sure if it really will count up as a planet, but we'll just have to see once we find it. Now, as for planets outside of our solar system, there are so many varieties and different kinds of orbits for them, that we may have to be a bit more lenient of what a planet is, because in some cases the differences between planets can be a bit blurry of what a planet could be or should be is quite hazy at times. Um, because some planets that we found are quite small, um, barely bigger than Mercury, while others are truly gigantic. For example, recently they found a large um, planet or brown dwarf orbiting another star in the galactic core. Now it has a mass of 13 Jupiters. So, yeah, with that one, it's a bit hazy whether it's a true planet like Earth or whether it's a brown dwarf. Now, brown dwarf is a failed star. It now it began to form like a normal star, but it never reached the size and mass, especially the mass, to start hydrogen fusion in its core. Well, through hydrogen fusion, like in the sun, for example. Um, Brown dwarfs are able to fuse simple forms of hydrogen, deuterium, um, but proper hydrogen fusion, like in the sun, just doesn't happen in brown dwarfs. So, with this massive 13 Jupiter massed object, we're not sure if we should qualify this as a planet or brown dwarf. Um, Further research needs to be done on this object. So until then, it's doesn't quite qualify as either. But most objects orbiting a star up to about 10 Jupiters should qualify as planets. Um, with rocky planets, or at least some types of planets, it also gets a bit blurry because you have different kinds of planets. For example, you have the sub-Terran. Um, Now, a sub-Terran planet is any planet that is smaller than the Earth. For example, Mercury, Venus, and Mars are sub-Terran, while Terran planets, I hope I got that part correctly, are basically planets that are um, basically the same size and mass of Earth. Then you have super Earths. Um, Now, super Earths are planets that are larger than Earth but smaller than Neptune. Basically, between about 1.5 to 10 Earth masses. Those are super Earths. Then you have the Neptune to Uranus sized and mass objects, planets. However, here the line gets a bit blurry because a few years ago they found this large rocky planet. Um, yeah, I need to look up the name on that. Um, okay. Because right now I don't have the name on me, but in my next video I will mention the name. But this planet, I think I may have mentioned it in one of my previous videos. Um, but in case I didn't, um, this planet is a rocky planet and it has a mass of 17.2 Earths. Yeah, 17.2 Earth masses. Basically, um, yeah, 17.2 Earth masses. That's pretty hefty for a rocky planet. Normally, planets with a mass of 10 or more Earth masses are either ice giants like Uranus and Neptune, or gas planets like Jupiter and Saturn, though Uranus and Neptune are also qualified as gas planets because they also have a large amount of hydrogen and helium. Um, yeah, with Uranus and Neptune, they qualify as gas planets um, and ice giants because they have a thick mantle of water and ammonia and methane, for example, which are normally ices or ice at the distances that they are normally. So they qualify as gas and ice giants. So planets with a mass of 10 or more Earth masses are, no, are normally gas or ice giant planets normally, but with this planet, it's a rocky planet with a mass of 17 Earth masses, plus or minus one or two Earth masses, but at about 17 Earth masses. Um, how it could have possibly formed? Um, yeah, it's ow, just bit my own tongue. Ouch. Ah. Um, how it formed? Um, the models that we have for rocky planets like the Earth and gas planets, Jupiter, Saturn, Uranus, Neptune, um, they fail with this planet. Um, though, I'm not sure if anyone has thought of this yet, but it's possible, and I actually read something similar in another article that some rocky planets um, that are termed lava planets or magma planets. These are planets that orbit, or rocky planets that orbit so close to their host stars that they are basically molten. They melted and are basically they have lava all the way through from the surface to the core. So you have this big ball of magma orbiting the a star. Um, yeah, with some of these rocky planets, there could be the remains of gas planets, hot Jupiters, hot Saturns, Uranuses, and Neptunes that used to orbit their stars so close that they basically their hydrogen, helium, and other components just basically vaporized and got blown away by the star's solar wind, leaving behind the rocky and metallic core um, as a big blob of magma. Now, the idea that I got, which is probably highly unlikely, but probably gives an explanation of how it may have come about. Here's the thing. Um, at some point, a large gas planet, possibly as big as um, Jupiter, got started orbiting its star closer, and with each orbit it got closer, gradually losing mass. Its hydrogen and helium um, atmosphere components got blown away by the star's solar wind. Eventually, after millions of years, all the planet's hydrogen, helium, and other components got blown away, leaving behind this massive rocky metallic object with a mass of about 17, maybe 20 Earth masses. Yeah, 17 to 20 Earth masses when it first formed. Then eventually, because of gravitational interactions, possibly with another star, um, possibly the one that it now orbits, um, captured it. Either this planet got captured by the star it now orbits, or it got kicked out by other planets within the system and then got captured by by the star it now orbits. Either way, um, this planet may be the remains of a gas giant, possibly the size of Jupiter. Um, as for the here's the thing. From what we've observed so far, it it's a rocky planet with a high amount of water, liquid water, as far as we can tell. So it's possible that when the star that this planet now orbits captured it, this planet may have along the way captured a large amount of ice, which we now see as water. And yeah, that's how this planet may have formed. Maybe the captured remains of a gas planet. Um, yeah, and then you have the yeah, that's my idea for now for this planet. And then you have planets like Uranus and Neptune um, that have a high amount of water, ammonia, methane, and hydrogen, helium around a rocky metallic core um, that are that have a mass of about 10 to 20 Earth masses. Sorry about that. Um, then you have Saturn-sized planets. Um, yeah. Fun fact. Um, James Cameron's movie Avatar with the Na'vi, those blue alien people. Um, yeah, actually exists. Yeah. They found a solar system similar to the one in that movie. Um, you have this star with this large um, gas planet. Okay, I'm not sure how big this planet is, but it's at least in the okay, in the movie, um I'm not sure how big this planet is in the movie, but I'm guessing Saturn size. Um, and then with this moon or moon slash planet, um, for its mass, I'm guessing that it's perhaps. I'm guessing that the mass of this planet is about roughly equal to that of Venus. Um, you see, for this moon to have the characteristics that it has, it I'm guessing it has to be about the size of Venus because a few cases for this is one, the Na'vi, for example, and the other aliens that we see on this moon are far larger than the people shown. So the gravity is much lower. Also, the trees, for example, the Na'vi mother tree, for example, is much taller than any tree here on Earth. And yeah, so the gravity for this planet or moon is much lower than Earth. So this mass of this moon is smaller than Earth. Also, but the mass of this planet or moon is high enough for it to have a thick enough atmosphere to have liquid water. Um, so this moon should have a mass high enough for a dense enough atmosphere for liquid water, but low enough that the plant and animal and humanoid um, life is much bigger, taller um, than life here on Earth. So I'm guessing it's like I said before, this moon is roughly equal to that of Venus. So this gas planet and moon actually exists because astronomers have found a similar system to this. Um, I will look that up today, and with my next video I will give the name, but they found the star with a super Earth sized planet and a Saturn sized planet in the habitable zone. So James Cameron's Avatar movie could exist. And then you have the Jupiter sized planets, and then the super Jupiters. Basically, ju- planets, gas planets that are bigger than Jupiter's, but only up to a mass of about plus or minus 10, 10 Jupiters. And yeah, I've actually talked long enough about this. Um, yeah, I need to wrap this up now. I've been talking long enough, but I will see you guys in my next video with more planets. There I will give the name of the massive rocky super Earth or Godzilla Earth, and also the system that they discovered with Saturn or the Saturn sized planet. And that's it for today. See you in my next one. Sorry for wrapping this up now, but I've been talking long enough. Cheerios!